Hello everyone, and welcome to day 6, trigonometric functions. Last class you guys created a sine curve using the unit circle, and we talked about that quite a bit in length. I do want to go over it just in case you guys had forgotten what we talked about. So a sine curve, if we look at a sine curve, remember that if we have the unit circle at 0 degrees, sine is the y value. So we're at 0. At 90 degrees, pi over 2, it's the y value, we're at 1. At pi, back to 0, negative 1, and then back to 0, and we know it looks something like this. Drawing 2. Now, that is sine of x. If we had cosine, cosine starts at 1, it's the x value, and looks like this. And so that's a poor drawing, but you get the idea. It should probably look more like that. So you have the sine curve and you have the cosine curve. Very important to realize that the sine curve, if no transformations occurs, start at 0. Cosine curve starts at 1. So when we talk about this idea of what is a sine curve and how does it relate, we always go back to this Ferris wheel idea. And why do we like the Ferris wheel? Well, in a Ferris wheel, if we start at the bottom, it goes up and around and starts back again. And that's called a periodic function. Periodic function is something that is cyclical. It keeps going around and around. And we'll continue to talk about the idea of what a cyclical function is. Right now, just some questions to think about until we get to classes. What happens to this circle if it's a larger Ferris wheel? Does it slow down? Does it take the same amount of time to go around? What is it that changes? How does it change the degrees in a circle? We all know that the answer to that. What changes it on the actual trig graph? This graph right here, if the Ferris wheel increases in diameter or increases its speed. So we'll talk about more of that in class. Right now what I want to get to is these vocabulary words right here. So vocabulary words that we're going to look at are periodic functions. We talked about that already. Period, amplitude, and the y displacement, also called the vertical shift. So we're going to keep going down until we get to the summary, because we're going to go over the other stuff in class. A periodic function is cyclical. It never ends. Okay? It always goes on and on. It is the same idea as a trig graph. The Ferris wheel, it goes around in a circle and it never ends. It repeats itself. That's what cyclical means. Period. Period is how long it takes to complete one full cycle. Okay? And we'll talk about that in a little bit. Amplitude is the distance, if I can spell distance correctly, distance from the midline to either the max or min. Okay, maximum or minimum. And the y displacement is the distance from the midline. Actually, let's correct that. Distance from the x-axis. Let's go from there. From the x-axis to the midline. So we have these three are extremely important right here. Period, how long it takes to complete one full cycle. Amplitude, the distance from the midline to either the maximum or minimum. It's going to be the same no matter what. And the y displacement, the distance from the x-axis to the midline. It's also, if you want to think of it this way, how much was it shifted up or down? If we want to think of it, the function probably would be a better way to write that. So a little less mathematical terms here, and just how much was it? How much was the function shifted up or down? So take a minute, pause the video, and I want you to draw these graphs in. You already have them drawn in the booklet, but I want you to draw them in again. So take a minute, pause it, and draw them in. Okay, I'm going to go over all those terms now. So, periodic function. Does this repeat itself if it kept going? And the answer is yes, this would keep going. What I have shown you right here in the non-dotted area is one period. The period from here to here. How long did it take to complete one full cycle? All the way down till we hit its minimum. Kept going until we hit its maximum again. That is one full period. The period of this graph is 2 pi. It took 2 pi to go all the way around. Why does that make sense? There's 2 pi radians in one circle. That's how long it takes for one full cycle to be completed for a cosine curve. The amplitude. Let's look at amplitude. The amplitude. The distance from the midline, well, this is the midline, to its either max or min. Well, the maximum is 1, so the amplitude here is 1. And the last one is the y displacement. The y displacement is the midline. It's at 0, so there was no y displacement. We did not move it up or down. The midline is on the x-axis, and therefore the displacement is 0. If we wanted to shift it up or down, let me show you what that would have looked like. Say we shifted it up 1. The graph would have looked something like this. And again, we're going to get to this next class. But let's see what that would have looked like. Would have looked like this. The reason why the y displacement would have been 1 is look at where the midline is. It was shifted up 1. So if you would have looked at the green, the y displacement would have been 1 here. Okay, so we have period. How long did it take to complete one full cycle? Is 2 pi. That's how many radians are in a circle. Okay, that makes sense. Cosine curve is based on the unit circle. Amplitude, how far did it go up, is 1. Why does that make sense? Well, if you start at 0, what was a unit circle? What did we look at? The distance, or the radius was 1. So the highest point is 1 or negative 1. The distance from the origin was 1. That's the radius of the circle. And then the displacement, how much was it shifted up or down, was 0. Y equals sine x. In this case, we have how long did it take to complete one full cycle? Well, it should be the same thing, but let's look. Went to the maximum, back to the middle, back down to the minimum, and then back to where we started. Again, your period equals 2 pi. Your amplitude is 1, and your y displacement is 0. Again, how do we know it's 1? Midline to its max is 1, or midline to the minimum is 1. Amplitude is never negative. You need to state that. Why don't you go back up here? And amplitude. Amplitude is never negative. Another thing with amplitude, it can never be negative. The amplitude, which we talked about right here, is the radius of the circle. We couldn't write that in here. It's the radius of the circle. So that is examples of sinusoidal functions. Sinusoidal can either be sine or cosine curves. They are periodic functions. And we have learned that a period is how long it takes to complete one full cycle. The amplitude is the distance from the midline to either the maximum or minimum. It's also the radius of the circle. And the y displacement is how far the midline was shifted up or down. So let's go with one last thing here, and then we'll finish it up in class. If we are talking about the Ferris wheel, and in number 5, it says, suppose if the seat starts out at 3 o'clock. Seat's going to start at 3 o'clock right here. And we then complete one full cycle. Okay. How long will it take the seat to return to that position? And at what times will it revisit that position? So we're going to look here, and how did everything we just learned relate? I'm going to let you know that 25 is the amplitude. 30 is the y displacement. And so if we know that the amplitude, which we talked about being the radius of the circle, so from here to here is 25, and we know that we are shifted so that the midline is 30, right? What is the highest point? If here is 30, what is the highest point if the radius is 25? Also, what is the lowest point if the radius is 25? At what point did she get on the Ferris wheel? Or at what point was the highest point that the person was on the Ferris wheel? And then, how long did it take to complete one full cycle? So here are your questions to come into class with. How high? What position did she get on the Ferris wheel? And then the challenge question here is, how long, if the period is 2 pi, how long did it take the Ferris wheel to turn? And with that, I will see you guys in class.